Good morning and welcome into our Wednesday class here, bright and early in Taylor, South Carolina. Man, I am loving this spring weather. I hope you guys are enjoying it. I haven't been out in it as much as I would like to be, but plan on it. Once we get through our classes today, at least go for a walk. I went for a little short walk yesterday. Everything's looking good. Everybody's doing their work but me. I'm behind on grading, and I will somehow or another get that done. It is on my to-do list for sure. I appreciate everybody working so hard in this class. You guys are doing great. And we got a full class today. Only one guy that was expected to be here is not here. We had a few fallouts in this class, but that's to be expected on a course like this. Got a lot to do today, and we might as well go ahead and jump in. One thing I was going to mention, make sure I get my screen shared right here. Once one thing I wanted to mention is that you guys need to be thinking about registration for summer and fall. I know that it is hard to believe that it is time for that already, but registration for summer and fall starts on March 22nd. I don't know how much email you're getting on it and things like that. I don't get the student emails, so I don't know. But one thing I would suggest to you is you take a look at the schedules that have been posted. They were released on Monday, so you can see the schedules for the summer and the fall. Please realize that if you do not go to summer school, you should still go ahead and register for fall this cycle. It is a 2-semester registration. I'm going to type in the chat something that may be helpful to you while I'm talking here. I want you guys to touch base with your academic advisors and make sure that you're on track on your program. All of you should have been assigned an academic advisor by now, hopefully somebody in the CPT department. If I can be of any help to you, if you would like for me to look at it, I just entered a link in the chat there to an advising form, which gives me some background information. So when I look at your records, I know what you're kind of thinking about, so we can do our advising really quickly. Normally I can do it just through one email, but if you'll fill out that form, I'll be glad to look at your records and see where you are and what I think you ought to take in the summer and the fall. I'll be glad to help any way I can. Like I said, the schedules are up on gvltec.edu. They were up on Monday. Anything comes up on advising and you have any questions, let me know, or your academic advisor, whoever's assigned to you. If you have a problem with the schedule, if you're not finding the classes you thought you were going to find, that is a question for the department head, Philip Cluley. I have no control over that. All I would have to do is, if you ask me that, I'd just have to refer you. So if you have any questions about the schedule for the summer and the fall, touch base with him. So like summer school, I've always enjoyed teaching summer school over the years. A little bit smaller classes, we go faster. So we have 10 weeks instead of 14 weeks. And so that's kind of good in a lot of ways. With smaller classes, we can move quickly as a rule. So then we start back in August on our fall semester. So if you don't have any questions about advising, we'll go ahead and jump in our schedule for this class. This week is week number 9 in our 14-week semester. I know it's hard to believe that, and we're on unit number 9 in week number 9, how to work with numbers. And so you need to study up on that chapter. I know many of you have already done so. Post the topic for week 9, the topic 9. It'll be, what is it about? I forgot already, but I bet it's about numbers. And you only have one lab this week, and you're going to take one of our programs we've been working on and change how we deal with numbers in that lab. So it's going to be a good exercise for you. And so only one big lab this week. Then you have the quiz for your attendance too. And I think I sent you an email yesterday, maybe yesterday or the day before now, on a question snafu in the quiz, which one of our good, I think David's in this class. Yeah, David Dunn in this class found for us, and we got that fixed. David, I appreciate that. That's very helpful when you can tell me when there's an error there. And you guys might not know this, but David typed this really nice email and explained exactly what I needed to look for, and his professionalism in that email is appreciated. The thing that's kind of weird about Blackboard is they, because we scramble the questions up there, no numbers on my side, so I had to know verbatim the question so I could find it out of the test bank. And there are a lot of questions in the test bank, so that was helpful. Next week, we're going to take a look at strings again, dig deep into strings. And then we also have test number 3 coming up starting next week. So on the 15th, today is the 10th, 5 days from now, we have test number 3. It is going to cover unit 7, 8, and 9. It will cover today's unit, but not unit 10. So units 7, 8, and 9 and unit test 3 next Monday, Tuesday, and Wednesday. Very similar in structure to the first 2 tests. You kind of know how it goes now. And I'll post something online about it shortly. The review sheet should already be posted in Blackboard. You should have access to it. So that is our 3rd of 4 tests in the semester. Man, oh man, it's flying by. Any questions? Okay, well, that being the case, oops, let me make another adjustment here. And we'll get started with our unit for today. So unit number 9 is all about how to work with numbers. And you're saying, well, Bo, we already did numbers. And yeah, we did baby numbers. We did the first step in understanding numbers. Now we're really going to escalate. We're going to increase our skills on numbers. And we're going to learn, and I kind of teased this in the early units when things really didn't make much sense to you. I teased to you guys that we're going to come up with a way to defeat that floating point number problem we've been dealing with. And yeah, it's going to take a little more coding. I'll go ahead and tell you that. But there is a good way, a professional way to deal with the inaccuracy of floating point numbers. We're going to learn that today. We're going to take a look at not 1, not 2, but 3 new modules. And these modules, 2 of them deal with math and numbers. One of them deals with currency for us. And so we're going to learn these modules and learn how to implement them in the programs we already have so that we can use them through our experience in programs we have yet to develop. So I hope you guys got a nice cup of coffee. I couldn't get going in this class without a cup of coffee, man. I love it. So, so far we've been dealing with the basics of working with numbers. And we've learned how to initialize numbers, how to use arithmetic expressions, how to compare numeric values. Now we're going to learn in unit number 9 how to format numbers. We haven't really talked about formatting numbers. As a matter of fact, up to this point, we've had some annoying little output problems because of formatting, not the floating point thing, but I'll show you in a minute what I'm talking about. And also how to avoid the problem with floating point numbers. So we can deal with numbers better, I think, if we kind of understand the scope of what we're dealing with. So the first thing to kind of sink in your mind here in our advanced look at numbers is that integers, which are exact values, integers take 4 bytes of memory, okay? Every single integer takes 4 bytes of memory. whereas a float takes 8 bytes of memory. So float is twice as big in memory as an integer. So I think that's kind of interesting. In this little table here, you can see the lower and upward bounds of what integers and floating point numbers can do for us. So the largest floating point number, largest integer number we can have is 2,147,483,647, because when we go above that, we get past 4 bytes. Going in the negative direction in the other way is negative 2,147,483,648. There's one more than there is going positive. Now, as far as floating point numbers, we can go up to 1.7 E308. And you're thinking, okay, well, what is this E308 stuff? Stay tuned. We're going to learn about exponentials, because now that we have 8 bytes of memory to deal with floating point numbers, we can use exponentials to deal with the decimal places, basically, is what it's going to do for us. Also remember that floating point numbers can go up to 16 significant digits. That is a lot of digits. You can get a lot of digits in 8 bytes. Remember, one digit takes 1 byte, basically, if you want to look at it that way. So the way we're going to deal with floating point numbers, really big ones or really small ones, is going to be through scientific notation. Scientific notation consists of an optional plus sign or a required minus sign if you're going negative, a decimal value for the significant digits, the letter uppercase E or lowercase e, and a positive or negative exponent. So there are a lot of moving parts here. We're going to use the example 2.302 e plus 5. So we want to go positive with an exponent of 5, e plus 5, positive exponent of 5. So what does that mean? It's pretty simple. Don't make this harder than it has to be. What it means is if we're going positive, in this case, we're going to move the decimal point to the right 5 places. If we were going negative, we would move the decimal point to the left. But right now we're going positive. So if you can see on the screen here, our decimal point to start with is right after the 2. So because of the e plus 5, 1, 2, 3, 4, 5 places to the right, and then you can see that we're actually talking about 230,200. If it were a negative 5, we would just move the decimal point to the left, making it very small. So once again, we're starting with the decimal point after the 2, which would be right here. And so we're going to the left to make this smaller 5 places. 1, 2, 3, 4, 5. So now we have 0.00002302. So exponentials are pretty easy to work with when you're dealing with floating point numbers. Scientific notation is what we're looking at here. We have a few more examples. The most significant thing about these examples is that we could parallel this to the power of 10, okay? So if we were going plus 5, e plus 5, it would be the same thing as multiplying the number times 10 to the 5th power, or if we're going negative, the number times 10 to the negative power. We do have one example of a whopper here, 3.7 e minus 9. So the period is between the 3 and the 7. Count with me, 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't that fun? We move the decimal point to the left 9 places to get a really teensy small number with that float point. So we need to start raising our awareness of how we create, without really thinking about it, floating point numbers. because that is going to be a little bit of a problem until we get good at it, okay? So floating point numbers can happen, and it will not be apparent to you until you test your program, debug your program, and you see that the math results are not what you expected. And 9 times out of 10, that's going to be a result of a floating point number has kind of crept its way into your program. So in this example, you can see it's really easy to create a float point just by using the assignment operator. So we set balance at 100.10. Then we use the plus equals operator to add that same number 2 more times to it. And we come up with 300.30, right? No, we have created a float point and it is whacked out. It's not going to be exact for us. That is a problem. So floating point numbers are approximate values. Boo, we have to deal with approximate values. And we're going to keep looking at the best practices for dealing with approximate values. There's some things we can do. We learned about the round function already, and we're going to learn how to use the round function a little bit better this week. But floating point numbers will never be exact, okay? They sometimes cause float point errors that yield unexpected results. On the other hand, integers are exact values. So we should have the results that are anticipated when we deal with integers. Just realize as soon as you put that decimal point there, you're changing that integer to a floating point value. So as I said, it's just real easy to create a float point. So it is also easy, and this is something we've learned already, to use the round function to fix the problem to a certain extent. So now we have the balance that we thought was going to be the 300.30, and it was 300.2999999 and all that other stuff. So we'll put balance in the as the first argument in the round function, a comma, and then 2 decimal points, which those are the 2 arguments and have been the 2 arguments that we've used over and over for the round function. And so now we can just print the balance and we can see it's 300.3. So while I have the opportunity, I'm going to show you what I was talking about a minute ago when I said we have had some annoying output from our numbers when we don't see things that we would expect. We're going to learn how to fix that today. What I was talking about is that trailing 0 here. This should be 300.30. But because this is a float, any zeros on the right are dropped, okay? So just kind of catalog that away. It's going to come up in a little bit, and we'll see how we can use the format method to fix that, format method of the string. So the next thing we want to tackle is the math module. Now, I have a disclaimer here. I am not a mathematician. I probably have less math than a lot of you guys. I took college algebra before most of you were born, back in the late 60s. And so I probably forgot more math than you guys know. So when you start talking about trigonometry and logarithm and calculus and all that stuff, those big giant words, I would have to look all that up. I know how to look things up. That's the one thing I'm good at. So we have a helper. We have a math module in Python that makes all this higher level mathematics easier for us. So our task this week is just to get familiar with it. We're not going to use it a whole lot, but just get familiar with the math module a little bit. So the math module provides 4 functions that we should be aware of: the power function, the square root function, the ceiling function, and the floor function. Now, I am using a big giant word there instead of the abbreviation that they have. The POW or POW function will raise a number to a specific power. And so it takes two arguments, the number that we want to raise and the power that we want to go to. So it's real easy to use. Square root acts on a number, SQRT, and one argument's the number that you want the square root of. Seal and floor are kind of interesting because these round floats to integers, actually change floats to integers. So seal num will take the float point value up to the next integer. Floor goes the other direction and takes the floating point number down to the next integer. And every time's where that's all you need. Real simple little function that will fix things. Also provided in the math module is pi. And remember, floating point values can go to 16 significant numbers or digits, okay? So in this case, pi is going to go to 15 decimal positions. Remember, it starts off with 2 and then it goes forever. So this is the whole pi, is the biggest pi we'll ever need, I think. So to use the math module, just like other modules, we have to import it. Import the math module as M. We're going to use an alias here when we refer to it. So now math is M. And an example of the power function, m.pow, and then the number 2 to the power of 3. So 2 times 2 is 4. 2 times 4 is 8. That's how we get to 8. We cubed it. M dot square root. What is the square root of 16 in this case? It is 4. And we can also cube root, which is a little different than square root. Don't know that you'll ever need this, but you can do it with the POW function. So m dot POW. So m is the module, POW is the function we're pulling out of it. And 125. And the power that we want is 1/3. We're going down. We're going to find the cube root 1/3, 1/3. So that presents another really long float point number here, okay? So we can use pi in some examples too. Radius equals 12. So if we want to and that's the distance across the circle, right? So a circumference around a circle, m dot pi, we want to pull the pi function out, the value of pi, times the radius times 2 should give us the circumference. So pi r squared, right? And the area and the radius. This is another way to do the area. So notice the power operator. It was in the book. I don't know they explained it very much. I think we saw that like 4 or 5 units ago. But 2 asterisks are the power operator. So I want to make sure you remember that. That's a way to get an area of a circle. All right, so ceiling and floor, I think, are probably the easiest things we'll have to deal with, unless you want to be creative and take these out to decimal points rather than have them be integers. You could basically make them floats again. So we could do that with some creative math. So just remember, seal rounds up to the next integer, floor rounds down to the integer below. And so these functions return integers with no decimal places. So we could round to a specific number of decimal places if we use a trick that a lot of programmers have learned over the years. And when you say it out loud, people think you're crazy. Multiply the argument by 10 for each decimal place that you want, pass the result of that calculation to the function, and then divide the return value by 10 for each decimal place that you want. So why do you multiply it up and then divide it out? We're just moving the decimal point. That's all we're doing. So we'll see some examples of that here. First off, just examples of how the floor and seal functions work in the math module. And then that whole getting some decimal points out of it, creating a float. So if we have a number of 2.0083, that is a float, the seal will convert it to 3, which is into integer. But since it is a float, we could multiply that times 10 and then divide it by 10. And notice we do the multiplication inside the seal function. So we are moving the decimal point, and then we divide it to get the decimal point back to the right place. And that does work if you want to calculate the ceiling or the floor to a certain number of decimal places. Don't know that you'll ever need to know that. It may come up in conversation. I don't know, but now you know. It's in our book. Let's change the subject. Let's learn how to format things better. Let's learn how to format numbers as well as strings all at the same time using the format method of a string. Strings do have a format method in object-oriented programming. So this is pretty simple. We are going to create columns in our output. A column equals a field, okay? So we have some objective in our design of our output. We know what kind of columns we want. So we can use the format method of a string to do that. Now the syntax for this guy is tough, okay? I'm gonna be honest with you. The coding gets interesting because we have to provide a very specific, as you would imagine, a very specific specification for the format method prior to using the format method. So just kind of bear with me here as I try to show it to you. It starts with a quotation mark. The specification for the format is in double quotes always. That's part of the requirement, okay? And then inside the first quote on the left there, we have a left curly brace and a colon. So we got 3 pieces of punctuation before we've done anything. So it's always going to be a double quote, left brace, and a colon. And then we start building the format specification. Once we have completed that, then we will close the double quote, okay? We'll close the double quote right there. Actually, I jumped over the right curly brace, and then the double quote. Now we're going to see we have multiple columns. We're going to have multiple curly braces. So each column is going to be inside a pair of curly braces as we go along. Then we have a period. That period right there is very important. It separates the specification on the left from the format method on the right. And just kind of keep in the back of your mind, because it's going to make a difference here, we're dealing with numbers as strings when we do this, okay? So we will format a data item, which is a string, okay? That means this can be words, letters, or numbers. It can be anything, okay? So typically we're going to deal with the format width. Then we're going to have a comma or not. The comma is going to be the thousand separator, okay? And then we will have a period, and then the decimal places if we want decimal places, and a type code. All of this is inside the curly braces, okay? This is the syntax that goes in it. Yeah, this is a little testy. So we have some codes. 2 of these codes are important. D and F are going to be very important to us early on. D is for an integer and F is for float point. Do not ask me why they did not use an I for an integer. They decided on D for digit, I guess. I hope that's what it's going to be. But remember, a D does not have any decimal positions. Whereas if you want decimal positions, your type code has to be an F for a floating point number. We also have the option to do a standard percent, multiplies the value by 100 and puts a percent sign after it, just standard percentage. and we can do scientific notation by putting an E there. We won't get into a lot of that, but that is a possibility for a code, a type code. So here's some examples of format method of a string as it applies to numbers, okay? So the first example is a float point, FP number, float point, and we're just creating a float point number. Notice there is no double quotes on here. That's okay. We don't have to quote it because this is a float point value, okay? Now, when we use the print function, we just gave it a shot of steroids because now we can use the format method embedded inside the print function to do some snappy stuff with columns, okay? So inside we start with a double quote, left brace, colon, and a period, and then 2 and F, okay? We are not formatting a width for the column here. The column does not have a width. What we are doing is formatting 2 decimal places. It's always going to have 2 decimal places, even if that rightmost digit is a 0, okay? So that is just, all this just basically gives us 2 decimal places to the right of a period. And then we just run that into the format method. The right part on the right side of the period is pretty easy because that's the same kind of thing over and over and over again. So only difference here is we're going to 4 decimal places. Notice the comma separator here, that's the thousand separator right there. So in our format, we're specifying, it has to be after the colon and before the decimal points, because that's logically how it's going to show up in our number. So we want 1,000 separator and a period, and then we want to go 2 floating point digits or decimal points. And then we just run it into the method. Now in this example, colon 15 comma, we're specifying a column of 15 characters. We're also specifying 1,000 separator, and we want to go 2 digits on our decimal points. That's a lot going on there. Little footnote here. I will tell on myself, little commas there. After class yesterday, I went through and listened to my video a little bit, watched my video a little bit. It's the only way I can learn, hopefully do things better the next time I teach class. And I kept calling that the 1,000 separator. I mean, the thousands. No, it is the 1,000 separator. So just make sure that you understand that that is not necessarily in dollars, okay? It is in numbers. And the thing that's interesting about that is when we get to locale, it's not always going to be a comma. It could be a period, which is very confusing. Yeah, I just gave you another headache. Okay, so here's an integer. This is a little bit easier. Notice these are all D's, so these stay exact integers. But you can see that all we're doing is just formatting this as an integer, period, paragraph. Here we are formatting this as a integer with 1,000 separator there. Another floating point. We're doing percentages here. So notice the percent sign in the syntax. And notice the way we're dealing with the decimal point in the percent. If you want no decimal places, you have to specify that with percent. So 0, no decimal places, 1, 1 decimal place with our percent. Then here's that wacky exponential stuff. And so 2e on our float would output something like this, okay? This would take some testing. That's all I can say. We want 2 decimal places and we want it in exponential, okay? Or scientific notation. 4 decimal places, scientific notation. So we have 2 decimal places there. We have 4 decimal places here in scientific notation. All right. How's that for fun? Now, let's talk about the width of the columns. I think this is where we're going to get most of the bang for our buck here with the format method. Just realize when you create a column using the format method of a string, you are creating a left justified column. By default, it justifies to the left. That means everything starts on the leftmost point. And many, many times that is exactly what you want. But also other times you'll want it right justified. So we do have the left arrow and the right arrow operators to actually specify where we want the justification, okay? So if you want it aligned on the left, you could use a left arrow or just take the default. If you want it aligned on the right, use the right arrow, okay? And you'll see some examples of that here. Now in these examples, we have 3 columns, and the columns have alpha characters and numeric characters, okay? So we are going all over the place. We have floats and we have integers. So lots of example here just for syntax. There's no math going on here, nothing. This is all about formatting. Yeah, we created a lot more code, but we got a lot more professional looking output. Our columns are lined up. We have zeros all the way on the right when it's called for. So the first print method here is our heading. We want description, price, and quantity. Notice price and quantity are aligned on the right and description's aligned on the left. So using the syntax we just looked at, all we're doing here is setting up the columns. We're not doing anything else because we're using alpha characters. We don't need any kind of decimal points or anything like that. So we want to set up a 15 character wide column. We want to set up a 10 character right justified column and a 5 character right justified column. We just run it into the print to the format method. And then for those 3 columns, we have 3 arguments. And notice these are strings. They're enclosed in double quotes, description, comma, price, comma, and quantity, QTY. Next row is going to continue with the 15 characters on the leftmost column. Then in our first column, notice we don't have to deal with that right justification now that we have the heading done, by the way. You could put a right arrow there in front of the 10 and it would work, but you don't have to, which is interesting. So :10.2f, so it's going to be a 2-digit float, and it's going to remain 10 characters wide. And the next one's going to be a 5 character wide digit column. And then we have the format method, and then we have alpha character in the left column, the word hammer, then a float 9.99, and then an integer 3. And we basically got the same thing again with different data in the next column. So if this was a catalog and had 100 items in it, and we wanted to maintain this format, a lot of cutting and pasting going on here. Be pretty easy to do, just cut and paste and change the data. So that's how the format method of a string works. And just remember, we're going to embed that inside the print function to get it to work right for us. Any questions about the format method before I go any further? Nobody saying anything or posting anything. Let's see, this is helpful in getting the alignment right. It's a pain trying to figure out how the right combination of tabs and spaces. Yeah, that whole thing about tabs and spaces is like rookie. Now we're going to do it like a programmer or a developer. Is it possible to center align columns? That would be a Google thing. You know, I thought about that yesterday. I didn't say anything about it in class, but there is such a thing as centering a column. And I don't know if that is in the code or not. It's not in the book. Let me just put it that way, Chris. We'll have to look that one up. I've never done it. I just do right and left. Now you get into when you take Python into a GUI environment or a web environment, then you got more code you can deal with. Okay, you got HTML, you got the whole GUI thing. So just realize everything we're learning right now specifically for console output, which I know is not as exciting as web and GUI programming. If we had a second Python class, we'd get there. It's in the book. Some of it's in the book. So if you want to learn some of that, please keep pushing through the book once we get through our 14-week class. So let's change our focus now to the locale module. The locale module is used to make our programs international. You're writing your program in good old Greenville, upstate South Carolina, and you're thinking that's all I'll ever have to worry about. But you get employed by BMW or Michelin and the game changes, or any of the hundreds of companies that support those big organizations here in the area. So now you go write some programming that may end up in France or Germany. It'd be very easy to do. And so we need our programs to work in other countries. And that's the goal of the locale module. We're not going to learn the whole locale module. Okay, we're going to learn a little piece of it. So once again, Google's a good thing. We can look up additional codes and things for these modules. And so in Germany and France, currency is formatted differently. The days of the week, the months of the year are spelled differently, look different. All that's handled by the locale module. We'll deal with the days of the week and months of the year and all that string stuff next week. Right now, we're thinking about numbers and currency, okay? And really, I want to focus on currency right now. That's the thing that kind of makes the most sense. But there's actually numbers come into play too because of that separator we were talking about. As a matter of fact, in Europe, they do the comma and the period exactly backwards from the way we do. So in the United States, for $1,002.50, we have a dollar sign, a comma, a 1, a comma, 2 zeros, a 2, a period, and a 5 and a 0. We grew up with that. We know that. But in some parts of Europe, it would be a plus sign instead of a dollar sign, a 1, a period, 002, comma, 50, and it looks like a typographical error to us. But the locale module will take care of that for us if we use it properly. Okay, so just realize not everything is the same as it is here in Taylor, South Carolina. We got to look at this as an international issue, international program. So I'm going to take a minute to go through these functions that are included in the locale module, not only because they're in the chapter here, but these are really going to elevate your programming strength, okay? So the first one is set locale. This is normally done early in your function or your program, whatever it is you're writing, okay? It sets the locale for the specific category to the locale for the specific country code and returns a string for that locale. If a category is set to uppercase LC underscore ALL, the locale is applied to all categories, which is kind of where we're going to start. Okay, we're just going to use all categories. So LC, that uppercase LC is for locale underscore all. So we want all categories. And if the locale is an empty string, which we're going to see this is very helpful. If we don't know where our program is going to be used, it could be used in France, could be used in Germany, could be used in, I don't know, Mombasa, Kenya. I've been there. So if the locale is an empty string, then the set locale function is going to attempt to set the locale to the user's default locale in their operating system. Your operating system has some sense of where you are operating from. So it will try to use that for the locale. If that is not possible, then set locale returns a code of C, a capital C. Now, that is important because if we have a code, a capital C, when things are not going right, we can use that. We can use that to do something else. It gives us the opportunity to do some more programming and say, okay, well, if all this hasn't worked right, then let's set a default. So we're going to try to use the locale where the user is working. And if that doesn't work, then we'll have a default. And we'll see some code that does that. Just an if statement, just adds an if statement. Love if statements, solves so many problems. The second of our three functions here is currency, and this is pretty easy. Currency, and then the number that you want turned into currency, and then grouping. Grouping is a named argument, so it would be grouping equals true or grouping equals false. It returns a specific number formatted as currency. If grouping is set to true, the number includes the 1,000 separators. So that's a lot of typing to get a comma in there, by the way, but that's the way it works. Now, realize that for currency to work, we got to set locale. That's why I said for all of these things, we need to set locale early, and then when we run the second function and third function here, they actually make sense. The third function is format, and remember the D and the F, those codes. So all that kind of comes together here with the format function. Returns the specified number formatted for the current locale. If grouping is set to true, the number includes the thousands operators or separators. So we'll see that some examples of that. So let's look at some codes here, and these are just three. There are a lot of countries and a lot of codes, and we'd have to look this up. So this is just the United States, the United Kingdom, and Germany, okay? Notice we have a short code and a long code. I would suggest, because I've just seen more of it in other programming I've looked at, to use the long code. The long code seems to be universal, but you can use the short code if you want to. It'll probably work in the US. But notice the currency format. We're focusing on currency here, and the currency changes fairly substantial. Look at Germany there. It has that plus and the dot and the comma all mixed up. And all we did in the United Kingdom is we changed the dollar to a pound. And so we're now making our programs international. So how do we use this module? We have to import it. We're going to go ahead and change it to LC using the alias. So import locale as LC. And then just like other functions, we use it pretty much the same way. We have to refer to the module every time we call one of these methods. So lc.setLocale, we're going to do this early, and we're going to use the codes that are in that module and function. So we have to refer to the module lc.upperLC_all, US. This is the short function. Notice it works on most Windows systems. That's kind of limited. Whereas if you did this long form code, it ought to work on Windows, Mac, and whatever other system you have. I just like the long form of this. It's not that complicated. And then here's that if statement I was talking about. If you want to have Python try to use the locale set in the operating system of the user, then you would use LC for the module dot set locale, and inside the parens, the first argument LC dot upper LC underscore all, comma, and then an empty pair of quotation marks for the second argument. Notice in all of these cases, the second argument has quotation marks around it. Now, if this does not work, it's going to generate a C. So right after that, we will have an if statement if the result is equal to an uppercase C. Then let's use the LC module to set locale to lc.upperLC underscore all, comma, en underscore upper US, okay? So we just set the default to US here if we can't change it here. That's kind of cool. So the whole grouping thing, the named argument we were talking about. So using the currency format. So now we know what the locale is. Here's the number that we want to convert. We doing this inside the print function. We do a lot inside that print function. Woo, we use it a lot. So here's the number and then comma and the named argument grouping equals true. And because the locale is set to US, it looks familiar to us, okay? And here's how to do digits, and here's how to do floats. That should look familiar to you because we just talked about it, except for that percent sign right there. Notice that percent sign. Yeah, they're dropping some more punctuation on us, syntax punctuation, which is a pain. When you're using the format function of a string in the locale module, the format specification begins with a percent sign. I can't help you with that. It's just, that's the way it is kind of stuff. Okay. I'm not any more excited about it than you are. It's one of those nagging things that we're going to have to remember. So, any questions? Seem to always go past it before I ask that. On the locale modules, anybody got any questions about that that I can maybe clear up for you? Any thoughts? I know you guys hadn't thought about making your programs support international use, but you know, now's as good a time as any to start thinking about that. So we've learned how to use the rounding function in the past, how to round numbers to a certain number of decimal places, okay? So what I want to impress upon you today is we need to think about where to use the rounding function with our floating point values so that we have less mathematical errors. Okay, so not only do we have to remember to round, but we have to think about where we round in our code. And basically the answer to that is to embed that rounding function inside your mathematical calculation somehow or another. You'll see what I'm talking about here. So here's an example of the problem. Now, I cannot express this any stronger if I try. You have got to test your math. Whenever you write a program, do the math with a calculator and then do the math in your program and make sure it calculates exactly the way you expect. That is the only way that you're going to be sure. And also run a bunch of different numbers through it to make sure it's consistently correct. Okay. So testing, testing, testing. So this little program just takes one user provided variable, a order total. It doesn't really add up a list of things or anything like that. It's just an order total. And it does some math. It calculates a discount, calculates a subtotal, it calculates the sales tax, it calculates the net value of the total. So think of this as a little example of some business math here, just business math. And notice we're off here. We're off by 1 cent on the subtotal. That is a floating point error. Here's the code that created the problem. Okay, look at it a second. Do you see a round function in there anywhere? Nope. And let's see if I can move this one step further. There's the calculation. Oops, I'm jumping all over the place here. Sorry, guys. I had to cough there and it made my brain flip. Here's the second page of code. And so we're going to see how we can fix this, okay? How we can use rounding to fix the problem. This code is where the problem starts. So the first example shows us the calculate the results, okay? I'm actually not making any sense here. This is the first page of the program. This is the second page of the program after it's been fixed, okay? Here's the second page with the problem. There's still no rounding going on here. Yeah, we got formatting here. We got formatting all over the place. That works great. We have column width, we have 2-digit floats, but they're still floats. This is still a problem. Thank you, Bo. I finally spit it out. Now here is the way to fix the problem. Remember a minute ago, I said we want to embed the round function in our math calculation, okay? Actually, I probably should have said it the other way around. Embed the math calculation in the round function actually makes more sense. So that is what we want to do. Calculating the discount here, we'll start a round function. Here's the math for the calculation of the discount. We want to carry it to 2 decimal places. This is the correct way to use the round function, not on the result, but on the calculation of the result. Let that sink in just a second, because in most little simple programs, this will work, okay? Not all, but most. So we're still using the float value here, but we are using the round function to minimize the damage. Does that make sense? So just restating the obvious here, floating point numbers are approximate values that can provide unexpected results. So one way to cope with this is to use rounding, but a more reliable way is to use the decimal module to work with decimal numbers, okay? So if you are going to be writing a business program that is significant, a business program that you want to do correctly, okay, you're not going to use the round function. You will use the decimal module, okay? And the decimal module is tricky until you get used to it. But the decimal module takes float out of the picture. Float is gone. We're dealing with decimal numbers. So we won't call them float values anymore because they're not. We'll call them decimal numbers, which is what they are, okay? So decimal numbers work like a floating point number, except they are exact values, not approximate values. What else is exact values? Integers are exact values. So when we use decimal numbers, we can combine them with integers, and it works because they're both exact values. That by itself should make using the decimal module significant. Okay, so I've done my sales pitch. Now here's the price to pay. To get something that solves this problem, there is going to be it's very flexible, and there's going to be some coding challenges, okay? I'm just telling you the truth. So to start, you have to import the decimal class from the decimal module. Please note that I have underlined the uppercase D's here for emphasis. That is on purpose. Then we're going to use something called a constructor of the decimal uppercase D class to construct an uppercase D decimal object from string values. To do that, we code a set of parentheses after the uppercase decimal class and supply the string for the decimal number within those parentheses. That creates a constructor, okay? So the task of constructors is to initialize or assign values to the data numbers or the data members of the class when an object of a class is created. We're using a constructor to construct, create, build, initialize, start, whatever you want to call it, a data member, a data object, okay? This is object-oriented program 100%, okay? So once you create those decimal objects, you can use most of the standard math expressions, arithmetic expressions that we have been using. We could use the math module if we wanted to, all that stuff. Basically everything is okay once we have a decimal object, okay? So you can code expressions that mix decimal numbers with integers because they're both exact values. I said that a minute ago. You cannot code expressions that mix decimal numbers with floating point numbers. You're going to either do floats or you can do decimals. You cannot mix them. If you mix them, you will get error messages. Okay. So just keep that in mind. And my problem with this, and I hinted at it earlier, is it's easy to create a float and not know that you did it. Okay. So we just have to think about things. So the coding is going to be a little bit more challenging than what we have seen in the past with floats. There's no question, no argument that float value numbers are much easier to deal with, even with the round function, than we're about to tackle with the decimal module. The decimal module is more complicated. Okay. So right off the bat with our import statement, we have to change this because we are importing a class. We have not done that before. From decimal module, import decimal class. That is why we have a capital D here. They couldn't be named the same thing. Remember, we're case sensitive here. So if you screw that up, you're going to get an error message. Okay. So from the decimal module, import the decimal class. Now, Bo's definition for a class is a group of functions and methods. A class is a group of functions and methods. And then you can say, well, Bo, isn't that the job of a module? A module is basically the file that contains the functions and methods. But how those functions and methods are basically containerized inside that file is the class's job. So think of it as just an organizational scheme, okay? So we have classes, and one module can have multiple classes, and actually most of them do. So we have just kind of gotten started on this. But that's why we learn Python programming, because of all these modules and therefore classes and therefore functions and methods that are already done for us. We don't have to write code for that. We just have to know how to use them. So let's see what we do with this decimal class, the uppercase D decimal class. Order total is going to be a decimal object as soon as we write this constructor here. This is a constructor. Decimal is the constructor for the decimal class, and this is the initialization. We're building this decimal object 100.05. So that is now an object-oriented, it is a decimal object. Now we have a second one here. We're constructing .1 as a decimal object for discount percent. And now we're just going to do some plain old math. This is just arithmetic here. And so our discount is going to be the order total times the discount percent. Our subtotal is going to be the order total minus discount. We're creating one more decimal object here with this constructor. We're initializing this constructor using the decimal class .05. Okay, so that is the tax percent. Now we can calculate the tax. We can calculate the subtotal. Life is good. We just programmed that thing as a object-oriented program by using decimal objects. No rounding, no inaccuracy, everything's perfect, okay? How easy would it be to create a float on the fly and not even think about it? Look at the very last thing here, just a value here. We're gonna set subtotal times 3.5. That 0.5 right there made test 2 a float value. Okay, you cannot do that. So that's the point they were trying to make there. I don't want to go to quantize till I give you a chance to ask a question about this thing. It's not too hard. I've studied it Monday and Tuesday. Today's Wednesday is the third time through. Yeah, I studied it last semester. I use it from time to time. David says, why aren't decimal numbers a standard data type instead of float numbers? You'll have to send that question to the Python gods. I don't know. Seems like an exact number would always be more desirable than an approximate number. I agree. I do not argue with you. And, you know, I do a lot of head scratching when it comes to computers and languages and all. I think that Python has gone through growing pains, and it started out very simple. Floats are very simple, very simple. And so decimals are not simple. Decimals are complicated. And so it took more programming to do decimals. And I have learned just reading over the years that operating systems and programming languages and all of this stuff changes. You know it changes. And so somewhere early in the going, they changed it. Now, there's a place for floating values. We're going to take a look at that here in just a minute. So don't think we'll never use float values, because we will. But we just need to know the difference between floats and decimal objects, okay? And decimal objects are exact values. That makes them a good thing. So that actually, David, helps me kind of morph over to the next topic, which is quantize. There's another method that is included in the decimal module called quantize, and I just think that's a cool name, but it really doesn't tell us what it does. It is the rounding method for decimal objects. So quantize basically does the same job that round does, or a similar type job. I don't want to say the same job, but a similar thing. So if we want a decimal object to have decimal points to a certain number of digits, we use the quantize method to do that, okay? Now, the quantize method is unique. It has a unique syntax, and it uses something that I call a template or a pattern. That's not what the book calls it, but you have to tell it in a strange way how many decimal places you want your number to be. So whenever necessary, you want to use quantize to round decimal values to a specific number of decimal places. And so you have to tell quantize in a unique way using a constructor how many decimal places you want. And so the example that is in the book, 1.00 would initialize this to 2 decimal places, 1.000 to 3 places, 4 zeros would be to 4 places, and so forth and so on. So it goes on from there. Once you tell quantize through this kind of constructor thing we're going to do, then we also have to tell it the rounding constant that we want. Do we want it to round even, round up, or round down? There's 3 of them, okay? The default is to round even. David, this is going to give you heartburn because you would think that would not be the default, but it is the default. So let me try to help us understand what round, half, even does. And notice these rounding constants for quantize are in uppercase. So let's assume that our value is 10.005. It would be rounded to 10.00. It would basically just drop the 5 at the end because 5 is preceded by a 0, which is an even number. If we happen to have a value of 10.015, then it would round to 10.01. So I don't know. I would not use that. I would change the default because I like to control exactly what's going on. For business math, the way we were taught when we were in grade school, once you get to 5, you round up. If it's below 5, you round down. So you can do that with the round half up constant, okay? It will round a number like 10.005 to 10.01. regardless of what the preceding zero was or lack thereof or whatever. In other words, that acts like your calculator. Round underscore half underscore up. Yeah. Makes the round function look a whole lot easier, doesn't it? So the syntax is also going to give you heartburn here. So the way that you use quantize here, you have your decimal object and you got to run it through the quantize method. The first thing we got to do is write a little constructor here that is going to be the template, the model, the pattern for the number of digits that we want. It's going to be 1 point and however many zeros we want in our digits, okay? They call that the positions code. That makes no sense to me. It's not a code. But anyway, that's what they call it. And then if we want to use a different rounding constant, which I would, then that will be the second argument inside the quantize method, okay? So here's just the definitions of the three rounding constants. And I think we kind of decided we like to round up. Notice it's even the first one here. Round down is the backwards of round up. It's just the other way. And then rounding even, which makes no sense to me. That must be the way they do it in Europe, so I can think. Being not traveled very much as I am, that would be, I just don't know. Anyway, how to specify the number of decimal places. We could do it all in one foul swoop, which is the way I would do it. So here we're writing a decimal constructor to initialize 10.005. My echo is talking to me in there about something. I set her off. That's weird sounding. Okay, so this is the constructor for 10.005. That is now making this count a decimal object. And now we can send discount through the quantize method here, and we're just going to initialize it for 2 decimal places. Now, this is using the even, okay, round half even. Let's do it for round half up. Yeah, there's another little import thing we got to do. From the decimal module, we have to import the rounding constant round half up, okay? So once again, we create our digital, our decimal object here. We initialize it with the constructor. We run it through the quantize method. Here's the constructor for the decimal points. Then we round half up in uppercase now that we've imported it. And so that 0.005 is converted to 0.01. That's the way I would think logically. So you're saying, well, hey, Bo, if decimal numbers are more accurate than float point numbers, why don't we just use them all the time? Does that sound familiar, David? There are 3 reasons why, okay? First off, float point calculations are much faster than decimal calculations if speed is of concern. Second, the code for working with float points is like light years simpler. I think we've established that. And then the third is that float point calculations are accurate enough for most programs if you use the round function properly in your calculations, not in your results, okay? So just that one little thing about using the round function in the calculation makes a big difference for the floating point calculations. So let's see what would happen to our little invoice program if we said, okay, let's write this using decimal numbers, okay? Because this is what your lab's going to be. You're going to take one of our programs and change it to decimal numbers, okay? So here's the code to get it to work right. And remember, 90.04 subtotal is the correct answer. We know that's the correct answer. So our book highlights the parts of the code that are different from the last time we saw the invoice program. So from the decimal module, we want to import the decimal class. Also from the decimal module, we want to import the round half up in uppercase rounding constant. Now I think maybe you're getting the idea. This decimal module is huge. It has all kinds of stuff in there, and we're just importing the parts that we want. So we set up choice, we set up our while loop. We've done this before. We start entering our data input from our user. So the first thing we're going to do is create a decimal object here with a decimal constructor, okay, that has an input function embedded in it, okay? So input from our user, the order total. And because we have it coded as a constructor here, that makes this a decimal object. And then also the order total, we want that to round like a business program. So we want our order total to go through the quantized method following the decimal 1.00 constructor here and use the round half up rounding constant. Little blank line here up under the prompt. And then notice we get into our, well, actually this is just calculating the discount, but we're using constructors here to create decimal objects. It's just that simple. Creating these decimal objects is not hard. Once you've done it a couple of times, you think that's no big deal. But it is a big deal once you have done a calculation. This is a accurate value calculation, exact value calculation. We are calculating discount. We have to run it through quantize to get it to round, okay? And subtotal, once again, we're setting a tax percent as a decimal object, okay? With our constructor there, run it through quantize here, round it up. The rest of this is plain old math with some formatting. Notice the formatting embedded inside the print function. It's just that simple. Notice we want 10 character wide columns with 1,000 separators. Any questions about this code? Got one more program when we're done. Okay, y'all are either asleep, slow typers, or whatever. I'm gonna move on. Our last program to look at, moving to the decimal module and decimal numbers, is the future value program. This is going to be a little different because we have 3 inputs from our users: the monthly investment, the yearly interest rate, and the number of years. You've seen this program before. Look at the output here. Notice the beautiful output. It is formatted exactly the way a professional would want it formatted. This is what your users would expect. Compare this to the future value program we've been using, which looks like a bunch of rookies. This looks right, okay? We have our columns that are justified on the right here. Our decimal points are right. Our dollar signs are right. Our 1,000 separators are right. It's a good thing. So let's look at the code and see how we did this. So first off, we're going to import the decimal class. We've seen that a couple times before. And we've seen before, we're going to import locale as LC, okay? Don't think that that should surprise you. So now as we go through, we're going to see decimal objects created. So here is our definition for the get future value function we're building inside our program. And it expects 3 values: monthly investment, yearly interest, and years. And so how do we calculate the monthly interest rate? We take the yearly interest rate, divide it by 12, and divide that by 100 to make it 8%. And then months is going to be years times 12. That gets the number of months we're going to deal with. So we're going to create a decimal object here. Notice we have no calculation. We haven't done any math yet for the future value. So we're going to initialize our a decimal object here to 0.00. It's not null, it just has no value yet. Okay, so we start a for loop here for the number of months. Notice all the math looks exactly like we've seen before. There's no difference other than we are using exact values instead of approximate values. And then once we get a future value, we can run that value through quantize to get it to 2 decimal points. There's the constructor showing us we want it to 2 decimal points. And then we return future value. So not a whole lot different than what we did before. We just have to import the right stuff from the modules. We have to remember to create the decimal objects, and we have to remember to use the quantize method to set the number of decimal points that we use. Here's the main function for that program. Much of the same, okay? We're just creating decimal objects here for monthly investment and yearly investment using the constructor that we have available from the decimal class. All the math is the same as what we saw before, so I'm not going to read all that. Then we're going to get into using the locale, okay? Because now we're getting into display. We just want to make sure we display. It's nothing to do with the math. We just want to display properly based on locale. So the result, we want it to run through set locale, okay? And notice, remember I said we're going to set locale early. So once we start talking about display, the first thing we're going to do is set locale. So lc.setLocale function, lc module.lc upper LC underscore all for the category. We want all the categories. And notice that we have the type code or country code set to nothing. We're just going to let set locale try to figure it out on its own. But we're going to write our if statement here, just like we saw earlier in the chapter. If result happens to be an uppercase C because our idea here did not work, then we'll go ahead and set to the English US country code. Notice the syntax here for line. This was not really discussed a whole lot in the book. I like this technique because it cuts down on the amount of code we have to type. So we are creating a variable here, which basically is the format for a line. And since we have a variable we can refer to, we can feed that into the format method, okay? So look at how we do this. This is kind of cool. So we want a 20 character wide column followed by a 10 character right justified column. We have 2 columns. So notice our print functions are using that line variable actually that we just created right here. It's an object. Anything's an object, I should say, pretty much in object-oriented programming. So line.format, we want to run this through the format method. So we are going to take advantage of that 20 character wide column, but there's not going to be anything in the second column because that's empty. And then, and this truncates, by the way, this line truncates. We're going to go to the locale module and pull out the currency method and actually currency function. And for monthly investment, we want to grouping equals true, our named argument here. We want to do that to get the 1000 separator where it's supposed to be and use the right character based on where this program is being run. It's a lot of typing for a comma, but if we happen to send this to parts of Europe, it would be a period, okay? And then notice how we refer to line here 3 more times. We run that into the format method. And now we have a string followed by a value, string, value, and then a string and no value. But we want this all to be actually, here's the value here. Excuse me. The value is actually going to come with the function, the LC.currency function. The value is here, and we are using the named argument true to get the comma or the period in there, and we're removing the new line character. We just finish out the module the way we have so many times before. Are there any questions about the code in the future value part, the parts that change, or the other code, but primarily the part in yellow here? Does everybody kind of understand what's going on? I don't know that I explained the way line is used here, but I think that's pretty cool. Nobody has a question? We're going to end up right on time. So here's our list of terms. You were expecting a really long list with all this new stuff we're learning. Not so much, not so much, just 10 new terms. And we have those terms in the summary, just a couple of slides here for the summary out of the book. And the second part, and then the things to do. Let's see, Logan is asking, how would we test the locale properly without actually going to another country? Just use that, the country code, just the empty quotation marks, so test it. That's what I'm assuming that's what you're asking, because that's how the function works. Okay, we'll go back here to the code right here. That does the test for you. This whole block here from there all the way down to here is taking care of that test for you. It says test to see if there's anything we can use from the operating system that the user is using. If not, we're going to use this. So that's the test. Okay. So things to do this week. Thank you for your question there, Logan. Things to do, read the chapter. It's not a very long chapter. Download the slides if they will help you. I hope they will. Somebody's downloading them. I think they're good study tools. And complete and submit your topic for the week. You have one big lab on page 267. You're going to go through the invoice program and raise the bar. So you're going to change that to a decimal program, decimal numbers instead of floats, and do your quiz. Now I got the quiz working. If you did your quiz early, you might want to do it again just to take advantage of the question that was corrected. And I sent you an email and it's a post in Blackboard under announcements what I changed in case that impacts you. And I appreciate David once again pointing that out for me. Has anybody got anything else they need today? Any other questions? All right. Well, that being the case, I will see you guys next Wednesday morning. We'll do unit number 10 next week. Don't forget, watch your inbox, watch our site in Blackboard, our page in Blackboard, because we're going to start our test on Monday. Unit test number 3 on Monday, March the 15th. It'll be open for 3 days, okay? And hopefully the review sheet is enabled. I'm going to check as soon as we end class to make sure it is, okay? So that's coming up Monday, Tuesday, and Wednesday next week, unit test 3. Have a good week, everybody. Enjoyed class today. Thank you.